Question 807. A particle is moving along the x-axis for t is from 0 to equal to t is equal to 1. The velocity of the particle at time t is given by this, and the particle is at position x is equal to -2 at time t is equal to 1. Find the time t at which the particle changes its direction. Okay, remember the particle changes its direction whenever its velocity changes its sign from positive to negative or the negative to positive, right? So whenever velocity changes its sign from positive to negative or negative to positive. Here we have a velocity, right? So velocity is 2t minus 1 times e to the t squared minus t. And this exponential expression is always greater than 0. This is always positive, right? So velocity is equal to 0 when t is equal to 1 over 2 from this expression, right? So we're gonna test. Here's the time t. Here's the 0, right? Between 0 and 1, this is our interval of time, right? So velocity is equal to 0 when t is equal to 1 over 2. So far so good. Now substitute any value between 0 and 1 over 2. Let's say 0.1. So if t is 0.1, velocity is 0.2 minus 1, which is negative here, right? What if we plug in 0.7 here? If we substitute 0.7 for t, then that's going to be 1.4 minus 1, positive, right? That's positive, okay? So velocity changes its sign from negative to positive at t is equal to 1 over 2, right? So the answer must be equal to t is equal to 1 over 2, all right? That's the time where the particle changes its direction from negative to positive. Question 808. Write but do not evaluate an expression involving one or more integrals that gives the total distance traveled by the particle from time t is equal to 0 to time t is equal to 1. When a particle is moving along the x-axis, which is a straight line, the total distance traveled by the particle from t is equal to 0 to t is equal to 1 is given by definite integral from 0 to 1 speed of the particle dt, right? That's our formula. So that is equal to 0 to 1. Well, speed of the particle is absolute value of a velocity in the line, right? So absolute value of this velocity, which is 2t minus 1 times e to the t squared minus t dt, right? That's our integral expression for the total distance traveled by the particle. Question 809. A particle is moving along the x-axis for t is from 0 to 2. The velocity of the particle at time t is given by v of t is equal to 2t minus 1 e to the t squared minus t. And the particle is at position x is equal to -2 at time t is equal to 2. The question is, what is the position of the particle at time t is equal to 0? Okay, basically to find the position of the particle, we're going to have to find the antiderivative of velocity, right? So we're going to integrate this velocity v of t dt. But here, when time t is equal to, our position is -2, right? And we're trying to find the position of the particle at time t is equal to 0, right? So I'm going to write 0 here and 2 here. Then that's going to be, by the fundamental theorem of calculus, position of 2, right? Minus position, which is antiderivative of velocity, of 0, right? So from 0 to 2, our velocity is 2t minus 1 times e to the t squared minus t dt. And x of 2, when t is equal to 2, our position is negative 2, right? So that is equal to negative 2 minus x of 0. So far so good. Now we're going to have to solve this definite integral, and we're going to use u substitution. Let u, I'm going to write right over here, u is equal to t squared minus t. Then our du is equal to 2t minus 1 times dt, right? Here we have 2t minus 1 and dt. So that's going to be our du. And here t squared minus t, that's our u, right? So that's going to be e to the u du. And when x is 0, u is 0 minus 0, right? When x is 0, u is 0 squared minus 0, which is 0. When x is 2, our u is 2 squared, right? 2 squared minus 2, which is equal to 4 minus 2. That's 2, right? So our lower limit, upper limit doesn't change. It's 0, 2 here, right? So that is equal to negative 2 minus x of 0. And let's find the value of this definite integral. That's going to be equal to e to the u from 0 to 2, right? So that's e squared minus e to the 0. That's negative 2 minus x of 0, right? So e to the 0, that's 1, right? This is 1. So our x of 0, the position of the particle at t is equal to 0, is equal to negative 2 plus 1 minus e squared, right? Which is equal to negative 1 minus e squared. This is our position of the particle at t is equal to 0. Question 811. A particle moves along a line and its acceleration is 60 plus 2 at time t is greater than or equal to 0. Find the position s of the particle at any time t if its velocity and position are 1 at time t is equal to 1. Okay, in order to find the position of the particle, we're going to have to find the velocity first, right? Here it is given that the acceleration is 60 plus 2. So we're going to integrate this acceleration to find the velocity, right? So velocity is equal to integral acceleration, which is 60 plus 2 dt, right? So that's going to be equal to 6t squared over 2 plus 2 times t plus constant c. So that is equal to 3t squared plus 2t plus c. That's our velocity, right? It is given that at time t is equal to 1, our velocity is equal to 1, right? So when t is equal to 1, our velocity is equal to 1. So 1 is equal to 3 plus 2 plus c. Our c is negative 4, right? So our velocity is 3t squared plus 2t minus 4. So far so good. Now let's find the position s. S of t is, the position is anti-deliverable velocity, right? So we're going to integrate this velocity, 3t squared plus 2t minus 4 dt. So that's going to be equal to 3 times t cubed over 3, 2 times t squared over 2 minus 4t plus c, right? So that's going to be equal to t cubed plus t squared minus 4t plus c. That's our position. And when t is equal to 1, our position is also equal to 1, right? So when t is equal to 1, our position is equal to 1. So 1 is equal to 1 plus 1 minus 4 plus c, right? This is negative 2. So negative 2, if we add to each side, 1 plus 2, that's a 3. So our c is equal to 3, right? So our position s of t is equal to t cubed plus t squared minus 4t plus 3. This is our answer, right?